Hey guys, Mr. Corbin back with you again. Lesson number 2 on scientific notation. Got my good friend here, Miss Powell. And Miss Powell, we're going to be moving now from standard form to scientific notation. We started out going from scientific notation to standard form. So just a quick review on scientific notation. Scientific notation is a way, kind of an abbreviation of writing really, really big numbers or really, really small numbers. And we use the example, it's called scientific notation because you use this in science a bunch, maybe like measuring the distance between Earth and Mars, or maybe even looking at something microscopic where the numbers get really, really small. So we're starting now with the big number and going to scientific notation. So tell us, Ms. Powell, what are you thinking here?
Okay, that's the first thing you need to decide. Is this a really big number, like something that would be, and when you say really big number, we keep saying the example of going out to space.
Right.
But in science, if anything is bigger than 1, then that's considered to be a big number.
Well, these science people, you know how they are.
Yeah.
They're kind of strange.
So
Yeah.
is this number bigger than 1? Then you say yes. So this is called a big number. If it's a big number, then we know it's going to have a positive exponent.
Right.
So, and remember where the exponent goes. It goes above or to the right of that 10. So I got to figure out that number.
Right. And again, scientific notation, remember, is you have a number that starts to the left, and it has actually one number to the left of the decimal. We call it the coefficient, and it's times a power of 10. So we know that our exponent, the power of 10, is going to be positive because, like you said, this is considered a big number. Okay.
Now, this standard number doesn't look like it has a decimal point, but you have to understand that if it's a whole number, the decimal point always falls at the end.
That's a terrible decimal point.
It's big.
It looks like a multiplication. But I like that too, Miss Powell, because think about money. If you have $5, we would write that as a decimal 5.00, right? And so anytime you have these big whole numbers, even though there's not a decimal written, there really is one at the end right there.
Now, if you remember from the last video, you are only able to have one non-zero digit in front of the decimal, which means it has to be that 3.
Right.
So the decimal point, when I write it, is going to have to be in between the 3 and 4. Doesn't matter how many is in the behind it to the right, but it does matter how many is in the front. Now all I have to basically do is count how many spots did I have to move it from there to there. So I'm going to make my blanks. 1, 2, 3, 4, 5, 6, 7. So now I can go back over here. I can replace it with this 7. It's going to be 10 to the 7th. Now,
so the number of decimal places that I have to move or jump to get to where there's only one non-zero number to the left of the decimal, that's my exponent, right?
Right.
Okay.
So then what I've got to do is write what the coefficient is. Now remember, scientific notation is supposed to be a short way of writing this. So you're not going to write all these digits. You're going to have the 3 included, the 4, the 7, and the 6. But once it starts becoming zeros, this is where it saves you time. That's all you have to put is 3.476.
Well, and remember too, back in elementary school, we learned we can add zeros on the end of a decimal, and it doesn't change the value of the number at all. We can add 100 zeros after that 6, and it doesn't change it. So they really don't count here once we've moved the decimal.
Right. Now, I don't like how I've left this because remember, a number can really only have one decimal point. So really, I just put this decimal there to help me know where it to be moved to. So
well, if you were jumping like I teach in my class, Miss Powell, then you would see that that decimal point moves to here, and then we erase it from there.
But I like to keep it as the standard number to where I understand that my old number of 34,760,000 is the exact same thing as writing 3.476 times 10 to the 7th.
Okay, now one thing that some students may get confused about here, Ms. Powell, how do you know that the 7 is going to be positive or negative?
It depends on what your standard number was.
Right.
If it's big number, and again, in science, being big means it's bigger than the number 1.
Right.
So when I pull up this example, is this a big number? Is this number bigger than 1?
Well, that's a small number because that's a decimal. It's less than one. One thing that I always do too, Miss Powell, is I always think to myself, if I put that number, that scientific number in my calculator, would that end up getting me back to what I started with?
Right.
So would it be a big positive number like you said, or would it be a small decimal number like maybe this one would be?
So since this is small, which is basically the same thing in science as saying less than one, then I automatically know that I have to have a negative exponent.
Right. You know automatically this is going to be negative because when you multiply it back, you want the number to be small.
So whenever I'm writing this down, I go ahead and put times 10 and I put a negative there because sometimes I forget. So
No,
immediately,
Miss Powell forgetting, I could never imagine Miss Powell forgetting
I
anything.
try to remember, is it positive or is it negative? Now, this front coefficient number, I can only have one non-zero digit in front of it. Now that means I can't stop right there because the 0 is not a non-zero digit. So the one non-zero number would have to be the number 1.
And you can think about that before you make jumps or before you
Mhm.
underscore whatever you do. You just know that there has to be a number other than 0 to the left of the decimal.
Right.
And it can only be a non-zero number. So what's the first one? It's going to be that number 1.
So it'd be 1.37. Now, I've never have filled out how many spots. So I'm
Right.
going to go back and count. 1, 2, 3, 4 until I get to the new spot.
That's how many jumps my decimal
Mhm.
would make to get to that non-zero 1.
Now, that means if this was my original number, that's my standard number. This is its matching number. Now, that means if I were to take a calculator and I put in, see if you don't get a glare, 1.37 times 10 to raise something to an exponent, I can use that little caret. And
What do you call it?
Caret. It's called a caret. It's not a house
It's a
top.
housetop. It's a rooftop. I call it a rooftop.
It's in math a caret. So
Okay.
1.37
You didn't know vinculum in the other video.
times 10 to the negative 4. I get the exact same standard number I had before. So that's one way you can check it. In case you have a calculator, that's what you can do is check to make sure that when you put in your scientific notation number, it gives you back your standard.
Yeah, and I certainly would do that, Miss Powell. If I had an opportunity to check with a calculator, I would do that every time. So
Okay, so let's go do a couple more. First decide, is this a big number or a small number?
that looks like a big number to me, Miss Powell.
Okay, so if it's a big number, it's got to have a positive exponent. So I'm just going to go ahead and put times 10. And I don't have to put the positive. I'm putting it there to remind myself. Now, again, it's a whole number. So where does that decimal point fall at the beginning of the standard number?
Well, again, I always think about, well, if I was writing that in form of dollars, it would always be after the last 0, it would be point and then 00. So we know it's at the end of the number.
Now, I'm going to have to keep moving it until I stop where?
Well, where is my first non-zero number? Well, if I'm moving down the line here, my first non-zero number is going to be that 4.
Okay, so do I put the decimal there?
But I wouldn't want to put the 4 is my first non-zero number, but how many non-zero numbers can I have to the left of the decimal?
Well, I can't have 4, so I got to keep it moving.
Right. So
can I put it there?
Nope, still got 3 numbers to the left of the decimal.
Can I put it there?
No, I've still got 2 numbers to the left of the decimal.
Can I put it there?
That's where we want to put it. We need 1 number to the left of the decimal.
Can I move it one more though?
But then I wouldn't have a non-zero number to the left of the decimal.
Okay.
So I've got to stop before the 1.
Okay, so now I've got to count how many spots that I moved it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it'll be to the 11th. And then all I got to do is block off all my non-zero digits, and that becomes my coefficient. So it's 1.374 times 10 to the 11th.
And again, that 11 tells me if I multiply this back in my calculator, I'm going to move that decimal 11 times. It's going to make my number big. Okay, so think to yourself, if I check this number, do I want it to get bigger or do I want it to get smaller? If I want it to get bigger, that's going to be a positive 11. If I wanted to get smaller to get back to the original, it would be a negative.
Now, just checking to see what my calculator will do. Okay, this time I was checking, and I put in that 1.374 times 10 to the 11th. It just spit back out 1.374 times 10 to the 11th. Sometimes when the number's too big, it's just going to give it right back to you in scientific notation. Now, some calculators will do other things. Can you hand me a graphing calculator back there?
You mean one of these real expensive ones that only
Really?
you got that the
Yes.
rest of us didn't get?
So no one else has these. Okay.
This pal's very special.
So you can do 1.374 times 10 raised to the 11th power. And this is giving it to you a little bit different. It says 1.374, then it's got E11. That's a way that some calculators tell you that the number is too long to show you on the calculator
Right.
screen. And that's a shortcut of saying times 10 to the 11th power.
Right. So the E just takes the place of the times 10
Mhm.
and then the 11th power right there. So if your calculator gives you that E, again, it's putting it in scientific notation times 10 to the 11th power. Okay, so you guys remember that out there, okay?
Okay.
All right, one more, Miss Powell?
One more. We need to be
All right.
finishing this up. Is this a big number or a little number?
Well, it's less than 1, so that means it's going to be a small number.
So it's going to be 10 to some negative number.
That tells me for sure I'm going to have a negative exponent for my power of 10.
Now, I only have a 5.
Right?
So I've got to think, do I stop the decimal there? Do I stop it there? Do I stop it there?
Well, again, I'm not going to stop it till I have one non-zero number to the left of the decimal. So it's got to be the 5.
Okay, so I got to count how many spots to move it, which would be 3. But I don't have anything back here. So what could I put?
Well, if you wanted to, you could put zeros, but would there be any reason to do that?
No. So you could just have a coefficient that's just a plain number.
Right.
5 times 10 to the negative 3.
Don't
Doesn't
let
have to have
that-
decimal
Yeah,
places.
don't let that throw you off your game right there. You just want the first number that is non-zero to the left of the decimal, okay?
So there's my standard number that I started off with.
Right.
And that's what it would match in scientific notation.
And the negative 3 comes from I have to move the decimal 3 places to the right to get a non-zero number to the left of the decimal.
And since that number is really, really small, you're dealing with negative exponents.
And thinking about checking this, if I was going to check it, if I multiply this back, would my number get really, really big or really, really small? Well, negative exponent means I'm going to get really, really small. Okay? And so that's what I want, right, Miss Powell?
Yes.
Okay. I think that's going to get it for this one, Miss Powell. And so we're going to get back to you here in just a little bit with another video. We will talk to you later. For Miss Powell, I am Mr. Corbin, and we'll say so long.